Okay, this is the wafer. This is the wafer I was telling, and each small square is nothing but integrated circuit fabricated. Now, I told you microcontroller having 40 pins, 20 pins and all. How that number 40 or 20 is decided? So based on alpha into gate count into gate count whole power beta. Okay. So this is the formula for number of pins that comes out from each IC. You have 741 IC, 14 pins are there. Okay, sometimes 8 pin IC is there, AND gate, NOR gate, NAND gate. You might have seen the ICs in digital circuits lab. And in that, those number of pins, number of legs is decided by gate count. Inside that IC, how many logic gates are used. Okay, into that whole power beta, and into alpha is also there. Alpha into gate count whole power beta. This alpha and beta are the constants which represent the type of material used in that gates. Logic gates are there inside the IC. So those gates, how it is made up of, what are the materials used, and what is the expectation, what is the speed of operation for them. So all those things will decide this alpha and beta value, which are constants. Device design. Alpha and beta will decide the device design, and then how many gates are there. So based on these three factors, we will decide how many pins or legs that should be taken out from that particular IC. Okay, so this is called Renz's rule, which will decide number of pins. Now coming to the packaging process. We are designing IC, we are fabricating IC on the top of wafer. Each of that square box is called die, DIE. Die means each of that square box is called die. Inside that square box, one circuit IC, integrated circuit, is present. Okay, so now that chip characteristics, each of that IC characteristics, okay, that will decide what type of packaging process to be followed. Okay, so what are the chip characteristics? Integration level, whether it is 1 level IC or 2 level IC. So what is the case? Wafer thickness. Based on wafer thickness, number of levels are also there. Sometimes 11 layers are also present, where metallization is used to connect all those layers. To a maximum of 11 layers may be present based on the thickness of the wafer. Next, chip dimensions. That square box I told you, or wafer I told you. So presently 12 inches wafer are available, and which is standardized. And after that 18 inches wafer is also in place, which is not yet in full establishment. Okay, so now the chip dimensions. Chip dimensions means you may take a small die, that square IC. So what is the chip dimension? Or the entire wafer, what is the dimension? All those things will decide what type of packaging can be done as the next step. Next step, environmental sensitivity. How it is getting affected to protect the IC from external contamination. Okay, to protect the IC from external contamination, we will decide what type of packaging is suitable. Next, physical vulnerability. We are handling that IC. Okay, we are handling that IC. We will take it and we will connect it for a bigger circuitry. All those things will take place. So during that, some damage may take place. So based on that also, we will decide what type of packaging will suit. Okay, for a longer life for the IC. Next, heat generation. How big is the circuitry? I told you that a die is present. So how big circuitry is there? How much power dissipation takes place? When power dissipation is there, heat will be generated. So there must be some heat absorption material which is called heat sink. Okay, so heat generation and heat sensitivity. So heat sink provision is there or not. Based on that also, we will decide what type of outer box packaging is required. Okay, so these are the chip characteristics which will decide the type of packaging for that particular IC or wafer. Okay, now what are those integration levels? Then wafer thickness and chip dimensions, environmental sensitivity, physical vulnerability, and finally heat generation and heat sensitivity. All these factors will be deciding the packaging type. Now what about packaging? What we will use in the packaging? You can see this is the last step after IC fabrication. Before it is sold out to the customer, before the final chip reaches the customer, we cannot simply give a loose IC, okay, to the customer. For example, you have the solar panels. Solar panels are very thin, okay, thinner than papad what we eat. So while handling, the whatever small disturbance caused the solar panel will break. So the solar panel is first of all attached to some mount, so that while handling it will not get breakage. Similarly, this IC also, integrated circuit also, we cannot handle them loosely, simply like that, immediate after the wafer, after each square box die. Okay, once the integrated circuit is ready, we cannot sell it to the customer just like that, because in the transport itself it will get damaged. So we have to mount them somewhere on a mounting surface, and then after that the final closing box packaging should be done. Okay, so after that only it can be sent to the customer. And here the packaging is the last step before the IC is reaching the customer. Packaging is the last step. Now this packaging is meant for protecting the integrated circuit. So as part of that, what are the materials that will be used? Silicon nitride or silicon oxide, which acts as hard layer. Otherwise soft layer means polyimide. These are the materials which can be used in the packaging. Packaging comes as different different materials are used in the packaging. For example, you have mobiles, isn't it? Or you have yes, we will take lunch box. We have lunch boxes. Okay, all our lunch boxes are not of the same material, outer material. So cost effectiveness is there, as well as health wise concerns are there. So different materials are used for making that box. Similarly, that similar to lunch box only, our packaging is going to be. And for that making packages, what is the material, raw material used? It can be silicon nitride or silicon oxide, and on as a hard layer. Soft layer, it may be polyimide. Okay, and then coming to why we are doing packaging, we are designing integrated circuit. Now it should come into the real-time existence. Okay, we have to use it practically. We should also make it possible for electrical connectivity. So electrical contacts, everything should be available, and it should not be loosely left. So we should be putting it on a mount and then give a closed package. And after that, we should see the legs of that IC also available outside for making the electrical contacts. Okay, so this is about the chip connectivity to an external system. Then packaging is done after the wafers are done with the fabrication, and also isolate the dies that are good and need to be packaged. I will show you in the next slide what is the meaning of this. In one, I told you, in single wafer, many small squares are there. Each square is having one IC. Okay, that each square is also called die. Before packaging, we should go with a process called testing. So in that testing, it will be decided which square is good, where the IC is fabricated good. For example, in one wafer, we are making 20 ICs. Okay, out of all the 20 ICs fabricated, all of them are not good. In the fabrication process itself, there may be some defects. So while testing, out of the 20, how many are good dies, how many are bad dies, that will be decided. And bad dies also, the profile. Profile means why it has gone bad. All those statistics should be maintained so that it can be resent for fabrication. Any minute defects can be rectified, it can be done, and again it can be made as a good die. So if more defects are there, we have to throw it out. So one single wafer, small squares are there, we will cut it each square separately after deciding which is good die, which is bad die. So bad die will go again for IC fabrication for minute corrections, and completely out of control, more damage is there or more defects are there, those dies should be thrown out. Only good dies we have to take it for further process, then only we have to do packaging. Okay, simply all the dies we cannot take and do packaging, it is waste of time and resources. Next, packaging also, we have a series of steps. Okay, similar to the assembly line process, in fabrication. Dies also will pass through final inspection and testing before it goes to delivery. Okay, so this dies means IC fabricated, that's each single square. So before it is delivered to the customer, it will go through a series of stages: inspection, testing, all those things, then final packaging, a series of steps in the packaging, then only it is delivered to the customer. Now coming to packaging, we are mainly concentrating on these 4 basic functions. While packaging is done, we are concentrating on main 4. Once we are doing inspection, everything, now good dies are ready. Now this good dies we have to do packaging. So while doing packaging, we are concentrating these 4 functions. What are those 4 functions? You can see here: electrical connectivity. So that IC is ready, even after keeping inside the package, whether it is available for external connections, that legs should come out properly. So electrical connectivity we have to take out, okay. And then physical protection. In that IC fabricated, there should not be any pits, any ups and downs, okay. All those things, physical protection should be there. For handling, it should be convenient, okay. That packaging should give good convenience for handling that IC. And then environmental protection, heat dissipation, all this should be taken care while doing the packaging, okay. So first one, electrical connectivity, then any physical protection is there, environmental protection is there, finally heat dissipation, okay. So you can recall electrical connectivity, physical protection, environmental protection, and heat dissipation also. And heat dissipation, you can see, if the IC is a bigger one, more heat is generated, bigger IC is fabricated. Integrated circuit is bigger if the die size is bigger. In that case, more heat is dissipated. So we have to provide heat sink in an appropriate manner. If that IC is a smaller version, we can provide a less heat sink. So in electron device, you came across this parameter called heat sink. Aluminum is used in the transistor heat sink, okay. As heat sink, aluminum is used, which means when the transistor is getting heated, this aluminum will absorb that heat, so that transistor will not burn out, okay. So similarly, this integrated circuit also, when heat dissipation is there, we should provide some material for absorbing the heat. So that is called heat sink, based on the IC size, whether it is big or small. Based on that, heat sink also to be provided, big or small. Next,